the concept of a blockchain arose in 2008. And the first sort of application of a blockchain was Bitcoin. So before Bitcoin, or sort of without Bitcoin, the way that value gets transferred between, like, let's say I wanted to transfer you $20. The way that happens is I go to my bank. My bank is keeping a ledger. I tell my bank I want to send $20 to you. My bank then communicates with your bank via 1960s ACH technology. Eventually, your bank has its ledger and it updates its ledger. And eventually, both ledgers reflect that $20 has been sent to you. The concept of a blockchain is actually, and this is the concept behind Bitcoin, is actually really simple. Instead of having my bank have a ledger and your bank have a ledger, and we just trust these banks to maintain these ledgers, what if instead we just had one ledger that everyone can see and that is stored on sort of everyone who is running the software's computers.
So everyone has a copy of it.
Right, effectively. And so everyone is sort of helping to maintain the software helping to maintain the ledger. And that ledger is decentralized. There's no one party, right, that can, like a bank, that can update it. So that's the sort of basic concept. And that ledger is called a blockchain. The reason it's called a blockchain is that essentially in Bitcoin, about every 10 minutes, a new block of transactions is added to the ledger. So all the transactions that occurred in the last 10 minutes. Mm-hmm. And so it's added to the ledger and it's now a blockchain. So the best way to think of a blockchain is really just like a stack of pages, right? It's really just a ledger. So that's the concept behind blockchain. Mm-hmm. And Bitcoin has, the Bitcoin ledger, right? And when one is transferring Bitcoin, what it means is you're just transferring on the Bitcoin blockchain, right? Your transactions are being recorded on the Bitcoin blockchain, and that's how value is being transferred. Other cryptocurrencies just have their own blockchains, their own ledgers.
So you can have different blockchains for pretty much whatever you want, as long as someone can build it for you.
Absolutely. Absolutely. So you can just copy the code from the Bitcoin ledger and create your own ledger, right? And that has the exact same code, works the exact same way. It's just you're starting from zero, and now that's whatever coin, whatever you want to call it.
Like some companies now are even creating their own intercompany blockchains for just, the people within their company. So not the public, right? Is that just to give an example of the uses?
Yeah. So the use case that is, I think the most common, that's very similar to what you're talking about, is these ICOs, initial coin offerings. And the idea is that you as a company can just create your own cryptocurrency, just sort of copy the code or create your own code and have a blockchain and sort of have your own ledger. So it could be whatever your company name is, coin, right? Mm-hmm. And what you can do with that is, sort of whatever you want. But one thing you could do with it is you could say, in order to use my product, like let's say it's some sort of online product or service, you need to be using my coins, these coins. And so you will go buy these coins and then use them on the platform itself. So maybe you'll pay per view of an article using this coin, and the money will get transferred directly to the company or to maybe whoever wrote the article, right? So there are all sorts of interesting things you can do.
So why is blockchain blowing up? What are the benefits to blockchain that aren't in the systems that we're using right now in transferring money and assets?
So a couple things. The first thing is these transactions happen effectively instantly. They happen with, in theory, zero, but in practice, low transaction costs. Mm-hmm. And they don't require centralized institutions. And I think sort of in the US, we take for granted that we can trust centralized institutions with our money. But I think that is actually a really powerful thing, to not have to trust centralized institutions in other places around the world. So for example, the first time that there was a huge spike in the price of Bitcoin back in, I think it was 2013, one of these sort of huge spikes happened because the country of Cyprus had sort of gone into everyone's bank accounts and said, we're just gonna chop off a bunch of some percentage of people's bank accounts and use that. Yeah. And so in the wake of that, the price of Bitcoin spiked. And the reason the price of Bitcoin spiked is because the demand for Bitcoin spiked. And the reason is that a lot of people saw what Cyprus had done with these bank accounts and was like, oh, it actually might be really useful to have our money in a non-decentralized type of system.
Because it is true. I mean, I think because we've had no other financial system other than pretty much banks or like having our money ourselves or held up in assets or something, that's the only way we know. So other than, we've just kind of trusted because we don't really have a choice, I guess. But when you really think about it, it is kind of, I don't want to say like tricky or anything, but like you hear something like that happen, you're like, well, yeah, I guess that is a possibility.
Right. And I think there are a lot of benefits even in countries where you do trust these centralized institutions. And frankly, the centralized institutions themselves have now started using blockchains just to increase efficiencies, between the banks or between, within sort of what we would think of as the established system. So there are also a lot of uses, in that sense as well.
Would we really need banks? I mean, yeah, I guess we would. I guess.
I mean, that's definitely a question at the sort of heart of the ethos of Bitcoin, right? Is the idea that definitely the ideal of Bitcoin coming from the cypher-punks, who sort of were the ones who were the early Bitcoin adopters, was that it would replace the need for centralized banks and currency.
And let's talk about, I know there's some other benefits that like are making this such a game changer. Yeah, I know security is one of them. So we were saying the speed of transactions, and real quick, can we talk about why it's so much faster?
Yeah, I think. And
how exactly it works.
Yeah, absolutely. The reason it's so much faster is it's a shared ledger, right? That everyone can see, as opposed to one institution having their own ledger and another institution having their own ledger and them having to communicate between it and update their ledgers separately.
And who works the transactions and approves them?
So the transactions are approved by consensus. So you essentially need, effectively, the software is, so the code behind Bitcoin, the idea is that there's this clever cryptography by which, as you are running, as transactions are happening, they're being validated by, in Bitcoin's case, at least 51% of sort of the computers on the network. And so as long as 51% of people agree, those 51%, that 51% of the network can validate transactions. So you may hear something about like a 51% attack in the context of Bitcoin. The idea behind that is if one party had access to more than 51% of the Bitcoin network, right, they could sort of put falsified transactions onto the network. But
which is possible, but very, very difficult to do, because you would just have to have an enormous computational resource in order to do that. Yeah.
So in Bitcoin's case, the Bitcoin network has more computing power behind it than, like, if you added up, there's some statistic, but if you added up hundreds of the world's most powerful supercomputers, right, and combined them all, the Bitcoin network still would be more powerful than that. And that's just because you have so many people running that software.
Right.
Other blockchains, though, right, that maybe don't have as much computing power behind them, are definitely more susceptible to something like a 51% attack.
Because it wouldn't be as difficult to get the computational resource to have over 51%.
Exactly.
Got it.
But the thing to note is, everything is publicly recorded. All these transactions are publicly recorded, right? So it is really easy, right, to then later go back and look and say, oh, look at these falsified transactions that happened. One thing that has happened is, or one thing that's interesting that about cryptocurrency is that you can just go back in time and duplicate the ledger and sort of just create a duplicate of the ledger that that sort of takes away whatever transactions you don't want to have happened, and that's called forking. So you may have heard of the Etherium Fork. Ethereum is another cryptocurrency that is definitely worth talking about, and the Bitcoin fork too. But the idea being that if you can take the ledger and sort of go back in time, and people can start using that ledger instead.
What would you want to do that for?
So what happened with Ethereum is, so Ethereum is a super cool application of cryptocurrency that allows you to essentially program your money. So if you've heard of so-called smart contracts, I find that kind of a misnomer. A better way to think of it is programmable money. So you can write computer programs that say, if X, then automatically transfer 1/1,000,000th of an ether or a Bitcoin to this other person. So you can have these automated things that happen, and sort of program your money to do things.
So it's like a programmable contract. So it's not like, oh, are they gonna actually send me this money when X is done? It's in the code. It's happening.
Exactly. And it happens automatically, and it happens at such a micro scale that there are all sorts of really cool things you can do with it. So like, for example, in the copyright context, you could write a program that says for every second of a song that is played by a user, automatically transfer 1/1,000,000th of a cent to the songwriter and 1/1,000,000th of a cent to the singer. And that all happens automatically at this micro scale. And what Ethereum did that Bitcoin didn't, Ethereum just made it much, much easier to do that kind of programming with your money. So one of the first big things that happened in the Ethereum world was the creation of what was called the DAO, the DAO, the Distributed Autonomous Organization. So the idea was we can actually automate an organization using Ethereum, using programmable money, essentially. And they sort of raised a bunch of money. A lot of people contributed a lot of money to this distributed autonomous organization, the DAO. And immediately it got hacked. There was a hack. There was a, not of the underlying ledger, right, but of the sort of things built on top of the ledger. And there was a, fluke in the code building on top of the ledger. It wasn't that the ledger itself got hacked, right? And a bunch of money, a bunch of cryptocurrency was stolen. And so what the Ethereum community did is they said, okay, well, why don't we go back in time to before this hack happened? And we'll just create a ledger that's exactly like the ledger, the Ethereum ledger, but we're just going to pick up at that point, that moment before the hack. And that was, and that was really controversial, and they ultimately did it. So right now there's Ethereum and there's Ethereum Classic. Ethereum Classic is sort of old Ethereum, which is the timeline of events where the hack happened. And Ethereum is...
So technically, Ethereum still exists. Oh, I'm sorry, Ethereum Classic still exists, but it's like, well, who was going to use that because it's vulnerable? So everyone has to agree to this fork, this change.
Right. So the Ethereum Classic itself is not vulnerable. It was not the underlying ledger that was vulnerable.
It was just at a certain point.
At a certain point, what happened is people built, so the ledger is just a ledger, right? And you build programs on top. Like you write code that says if X, then transfer some amount, right? That code built on top of it, of the ledger, is what allowed the hack to happen. It wasn't that the ledger itself was hacked, right? It's sort of like if your browser is buggy, on the internet, it's not that there's some underlying problem in the internet. It's that there's some bug in the browser, right? It's like a higher layer.
Yeah.
And so to clarify, it wasn't Ethereum Classic itself. It was just that the community said, well, we want to go back in time to before this hack happened. A lot of people lost a lot of cryptocurrency. We don't want to be in a world where these hackers have access to all this money. And so that is how this fork happened.
So how can they prevent that from happening again? If it's not the ledger itself and it's some, surface program or something, how can that not just happen again?
So that's just a matter of writing good code, right? That's an issue that is not unique to cryptocurrency, right? That's an issue that is a problem for banks, and everyone, right, has the same problem of making sure that your code is secure, right? And that's not an issue. My point is that that's not an issue of the cryptocurrency itself. That's just sort of a general problem.
Well, let's talk about the code a little bit, because it's the code that makes blockchain so secure. And I think that this is the part where I think people they know, they're like, okay, I get that they say it's supposed to be secure, but I think it freaks a lot of people out to put their money into a cryptocurrency and then just have it in the digital world somewhere. So are you able to speak to how the stacking of the blocks and why that's so much more secure than how we do things now?
Sure.
Or how you can't just like hack it, like you hear of people hacking other programs all the time.
Yeah, absolutely. So the idea is that you have this ledger, and what you actually see on the ledger is not that sort of Marta transferred X amount of Bitcoin to Michele, but rather you see
that would be a problem.
That would be a problem, right? Exactly. That's exactly right. But rather you see the public key. Essentially, you can think of it like almost like a username. Mm-hmm. And I can use a different username for every username. I mean, that's, you know. And I could use a different username for every transaction. Or I could, have one username that I'm constantly using. And then you have sort of like a password, a private key. And both of these things are just numbers. They're just a string of numbers. And so what it means to have cryptocurrency is just to have your public key and your private key. That's it. So if you want to store cryptocurrency, you could actually just store it on a piece of paper by writing down the numbers, that the public and private key, right? So because there's a ledger out there that has your public key, your private key is going to prove that that's you and allow you to make transactions. So all you need is these two numbers. Some people have what's called a mind wallet, meaning they just memorize their numbers.
Right.
But that's what it means to have cryptocurrency. And so in that sense, it's secure. Like the ledger itself has, there's the layer of security involving the ledger itself, but there's also the layer of security involving the users, right? Uh-huh. And in that sense, right, what you're really worried about is having those two numbers, like, keeping those numbers secret. And so that's what something like Coinbase does, these so-called wallets. Coinbase does other things as well. But if you hear of these wallets, all they're doing is storing these two numbers for you. There was there was something called Mt. Gox.
Yes.
Yes.
I've heard of this.
Yes. So this was early days. And Mt. Gox it actually stands for Magic the Gathering Online Exchange, MTGOX.
Of course it does.
Of course it does. And the
That's what I was
reason,
thinking.
yeah, exactly. And the reason that it is called that is because it was actually just an online exchange for Magic cards. And they were like, oh, there's this new thing, this new cryptocurrency thing. Let's also be an exchange. Not just for that, not just for Magic cards, right? And so they got hacked and they lost a bunch of sort of the public and private keys that people had been storing with them, and essentially lost a ton of money, falsified account balances, right? And so, and so that sort of shows you that's not some underlying problem in the ledger itself, which is secure. That's the layer on top of it. That's, the human element or also the, right, how you're actually storing those numbers.
That's a human error.
That's a human error, and also, right, a code error, like an error of the code that they've built on top of the ledger. Or in that case, of the code that they built in their system in order to just store your username and password.
So if you lose, and I've heard these two numbers, what are they called? You're saying the public
key, private key.
And the private key, I've heard them equated to like kind of an account number and then your PIN number.
Yeah, exactly. Username,
To kind of
password.
help.
One thing's public, one thing's private. Everyone can see the public thing. The private thing proves that you are the public thing, right? That you have access
And
to.
if you lose those, you're just kind of SOL?
That's it. You're SOL, right? And that's
wow.
that's right. And that's one of the things. That's one of the risks with cryptocurrency, right? Is, you know, in the U.S., your bank account is FDIC insured, you know, by the government up to $100,000 per account, right? You have this sort of insurance. You have this security there, and also, you know, that's not even to get into the fluctuating rates of exchanges, right? But that's not the case in cryptocurrency. If you lose, so you've probably heard of a lot of people losing their just the hard drives that they were maybe early miners in Bitcoin, and they just, you know, didn't think it was valuable at the time, and sort of their hard drive crashed, or they threw away their hard drive or whatever. Their hard drive was storing those usernames and those public and private keys, and once that's gone, that's gone. There's nothing you can do. There's no Bitcoin corporation you can call up on the phone and say, oh, I lost my username and password. That's not how that works. Yeah.
So doesn't that make it more, is it riskier to kind of put like any money or assets or whatever into this? And then if you lose that information, or if somebody has that information, that's essentially all you need. Or is that kind of the cost benefit? Like, well, yeah, it's riskier, but also you get the benefits of it being decentralized and deregulated.
Yeah. So I think that, again, that's the issue of keeping those layers, you know, secure is an issue that is common to not just common among sort of other, that's just a thing that is a problem generally. That's not specific to cryptocurrency, right? Like banks also need to be able to keep their ledgers secure and be able to keep usernames and passwords secure. And that's just a problem. That's not a cryptocurrency problem.
Yeah. Now, how is the code of blockchain so, I don't want to say unhackable, but kind of? I think because knowing a little bit of coding, that's what I became most fascinated by when I actually started, because I would, you know, Zach would talk about blockchain a lot. I'm like, okay, yeah, I'm kind of getting it. And once I actually got into like, okay, how is this thing actually programmed? That's when I got kind of really fascinated by it, because learning about, you know, the hashes and which essentially, I don't know, feel free to take over whenever you want, but that each block of all these transactions you were talking about, the blocks that, you know, build the chain, that they build off each other, and that, you know, you have the Genesis block, first block, whatever chain, and then the second block that is rooted in the first block, third block is rooted in those two, fourth block in those three. So in order to hack one, you have to essentially be hacking all of them, which is almost impossible. That's what I would find fascinating.
Yeah. So I'll simplify a little bit, but I'll sort of talk about like at a oversimplified way what's going on there. So again, oversimplifying and glossing, and I'm sure people will object.
No, I'm sure they'll appreciate that.
but my oversimplified, like, you know, non-mathematical way of explaining it is, so what you do is you have, you know, you have these previous blocks that you come up with some numerical, some representation for, and then you have this math formula. Like, picture a math formula, and what you're doing is you're looking for a thing called it's called a nonce. There's this number that all these computers are trying to guess, that when added to the numerical representation of all the other transactions that have already occurred, right? And when you run that through the NSA's secure hash algorithm twice, will come out with a certain answer. And that's how you are, and basically everyone is in a race. All your computers, what's happening every 10 minutes is all of your computers are in a race to come up with this nonce. And then once they fit, so all you're doing is it's a plug and play, right? You're just guessing and then plugging it into this algorithm and then seeing if what comes out is right? And once you have the nonce, right, the computer that sort of wins is the one that we know has the correct last 10 minutes of transactions, right? And so what happens is 51% of the other computers, or at least 51% of the other computers in the network say, okay, you've told us this number. We're going to run that through the algorithm now that you've guessed it. Oh yeah, that got us the right answer. So in fact,
to verify.
That verifies, right. And so that's what those 51% of computers are doing. So in fact, that is the last 10 minutes of transactions that can now be added to the ledger.
And these people are called miners. The ones that are figuring out this algorithm, the ones verifying all these transactions, they're miners.
Exactly. So this is the mining process. And so this is actually how, in the Bitcoin context, this is how Bitcoin is created. And so basically, everyone who's running the software is mining, and is also, and what mining is sort of, in so doing, you are basically just doing this process. You're guessing and verifying, right? And what happens is the person, the computer, once someone has guessed the right answer and therefore has added the last 10 minutes of blocks of transactions to the blockchain, that group or person or whatever gets a certain amount of newly created Bitcoin. So every 10 minutes-ish, a certain amount of Bitcoin is added.
And that's how they're compensated. That's their incentive for doing this in the first place.
Exactly.
Because without them, this would not work.
Exactly. So the idea is, by running the software, by maintaining the network, you are actually, entering yourself into a lottery in a way to win that brand new Bitcoin. And that's mining. And that's how Bitcoin is created and distributed in the first instance.
Got it. How, now you say Bitcoin is created every time someone figures out, does that mean that the number of Bitcoins out there is constantly, doesn't that do something to the value of it?
Yeah, so absolutely. So there will be only 21 million Bitcoins ever created. And essentially every 10...
Oh, they're mining, like gold mine.
Yeah, like gold mining, exactly.
Because there's only so much gold.
There's only so much gold. No, and that's actually a great way of like thinking about, like when you start thinking about like, why is Bitcoin valuable? It's extremely helpful to just analogize it to gold.
Because there's a limited amount.
Exactly.
People are trying to pull them out.
Exactly. There's a limited amount. It's a good store of value. It's valuable because people think it's valuable. And it's very divisible. Like, there are all sorts of really great analogies to gold. And when people say, well, why is this valuable? The answer is because people think it's valuable, and, just like gold, right?
Right.
But yes, so where were we?
well, why can't they just
Yeah.
Why can't they build more? It's just in the code? I know
it's in the code. In the Bitcoin
answer,
code, there can only be 21 million ever. And what happens is every so often, so the number of new Bitcoins created is halving every so often. So, for a while, there are 25 new Bitcoins created every 10 minutes. Then there's 12.5. Then there's half of that. Then there's half of that. So if you picture sort of the graph, right, you're sort of approaching 21 million. Like, as this number keeps, and so it'll be around the year 21 something that the last Bitcoin will be mined. But it gets harder and harder to mine Bitcoin, right? Because you're getting half the value of, every so often.
Wow.
Over time, right.
And what happens when you get there, when they're all mined?
Well, that's a great question, right? Because at that point, what's the incentive to be running the software? Right. And the answer, and that's a really interesting point, because there are also cryptocurrencies, right, that don't have limited amounts. So like when you talk about these ICOs, sometimes they will have a limited amount, but they just sort of have said they're going to have a limited amount.
But they haven't done it yet.
Well, I mean, if it's not sort of written into the code, there's nothing stopping a centralized company from making more, right? But yeah, that's one of the things that's so that makes Bitcoin something that's really tipped the market in a way, right? Is that there is a limited number. There's a limited amount, and that's part of what makes it valuable.
Yeah, because I would imagine if you can if there's no end to it, then I mean, this is kind of like just like printing money, right?
Exactly. Right.
Yeah.
And keep in mind, of course, that the US dollar, right, is not backed by anything in particular either, right? We used to be on the gold standard where you'd get a certain amount of gold if you wanted to, but that's not actually, we just print more money, right? So, the concept is not a new one.
Right. So in theory, we're almost going back closer to the gold standard.
Absolutely. Yep, absolutely.
Interesting. Hey everyone, thanks so much for watching the episode. If you're interested in contributing to the conversation and supporting the show, there's 2 easy things you can do. 1, click subscribe, and 2, visit our Patreon page where you get exclusive access to the Exploring Minds community.